find the domain of f of x equals 1 over x squared minus x. Thinking of the rules, the three rules of domains, we look for any of those showing up in this function. The three things are dividing by anything, doing an even root of something, or having a logarithm of something. And the only one that we have here is that we are dividing by something. So the rule says if you are dividing by something, then that thing cannot be equal to 0. So we take the thing that we're dividing by, which in this case is x squared minus x. And that thing, what we're dividing by, cannot be equal to 0. All right, so now we're going to find out which x values would work. So we solve this just like we would with an equal sign. It's just a not equal sign. So we're going to factor this. We factor an x out, and we get x times x minus 1 cannot equal 0. And this is a product here, so we're going to use the zero product property, which says that if you are multiplying two things, the only way to get 0 is if one of those things is 0. So that would be x or x minus 1. So this splits into two things. X cannot equal 0 and x minus 1 cannot equal 0. So we have x cannot equal 0. Over here we can solve for x by adding 1 to both sides, and we get that x cannot equal 1. So the domain of this function here is that x cannot be 0 and it cannot be 1, but it can be anything else. So we can write that in a couple of ways using set notation. Set notation. Okay, we say that our domain is the set of all x in the real numbers such that, which you can do with a vertical line or with a colon, and then x is not equal to 0 and x is not equal to 1. Or you can use interval notation. And interval notation, we write the intervals of our domain cutting out these points. And so I like doing this visually with a number line so you can see them. So I have to cut out 0 and I have to cut out 1. So that means I've got like a hole here at 0 and a hole here at 1. But I could be anything over here to the left, I could be anything in between, and I could be anything over here to the right. And then we can write these. Now notice that there's 3 intervals here. And so to write this, the first interval goes to the left forever. So I write it as negative infinity, comma, and then to 0. And putting a parentheses means it cannot equal that number, meaning x cannot be 0 here. And we also have the interval from 0 to 1. And so to include another interval, we put a U symbol here. It's actually a union, okay? Meaning we include both of these intervals. And we go from 0 to 1. And again, we can't be either one of those, so we get parentheses. And then our final interval is from 1 to the right forever, so that is from 1 to infinity. And that is our domain in interval notation.